Welcome to Frequency Matters, the RF Microwave Update series. I'm Pat Hindle. I'm here with my co-host Gary LaRude. This episode, we're going to continue our coverage of the October Passive and Control Components issue. As a reminder, the cover story was written by Soitec, and it talks about their new piezo on insulator engineered substrates for 5G front-end filters. And it's really unique that it can now be put the SAW filters right on the integrated circuit, so it can realize high performance and more compact RF modules for 5G.
Yeah, it's pretty cool.
So we covered the technical features last time. Can we take a look at products?
Yeah, we have 3 product features in this issue, starting with analog devices. They have a cool switch LNA module. Actually, it's a dual module for massive MIMO. They have 3 different products in the family, so they cover the bands from basically 1.8 up to above 5 gigahertz, so everything for 5G and also some of the 4G bands. It's a multi-chip module. They incorporate a high-power silicon switch with a gas LNA to get the best performance. Our second product is from Junkosha. They have developed a very rugged cable assembly that can be used in high flexure, high temperature environments. When it's flexed, it has very little amplitude and phase change, so that's good. And they offer 4 different connector styles, so you can go up to 67 gigahertz depending upon what connector you pick. And our third product is from RF Savi. It's an antenna coupler. It's developed for smart city light poles, so an installation where you can imagine a small cell or some other kind of radio mounted on a city light pole. And this basically isolates the antenna from the electronics in the pole or on the pole, also from the power for the light. So it protects the electronics from, say, a lightning strike to the antenna. Likewise, the antenna is protected from any kind of voltage, high voltage in the lamp. So those are our product features.
So for tech briefs, we had 2. We had 125 million samples per second arbitrary waveform generator that does multi-channel from Spectrum Instrumentation. And we had a second one. It's custom thin film filters and switch filter banks from Networks International. So two more to add to the list there.
Right, a lot of interesting products this month.
So turning to the news,
yes.
I wanted to cover some of the mobile news. We've seen the release of the Google Pixel 4, and that incorporates the 60 gigahertz Soli project radar for gesture control. So it's the first mobile device with radar integrated into the unit, which is amazing. I mean, 60 gigahertz on a single chip to be able to detect that kind of fine movement, it's very impressive. And then I also took a look at the teardown for the iPhone 11, and the big winner there, I think, is Skyworks. They had 6 RF modules in there. So everywhere from LNAs and GPS to PAs and all kinds of modules. And then Murata had 4, and Qorvo and Avago had 1. So it's always interesting to look at the architecture of the more advanced phones because you really get to see how they're isolating all the signals, and they still have to worry about GPS, Wi-Fi, and Bluetooth in addition to all the cellular bands.
Exactly, and it's only going to get worse with 5G.
What did you see in the news?
Interesting report that's just been released by Signals Research. They're a wireless consultancy firm. They do a lot of field testing, and they basically were contracted by Qualcomm to write a report that summarizes a lot of the work they've been doing evaluating 5G networks. So they released that this week. It's interesting, they evaluated 5G networks at 3.5 gigahertz in Korea, London, and Bern, Switzerland, and then they looked at 28 gigahertz deployments, Verizon in Minneapolis, as well as T-Mobile in New York City. They also did a recent evaluation of the deployment in the Minnesota Vikings stadium. Verizon is deploying in NFL stadiums. So some really interesting results coming out of that. Basically, as you would expect at 3.5 gigahertz, pretty good coverage. They're showing that 5G is doing higher data rates than LTE. Their work in Seoul was about 512 megabits per second, which was almost 2x what LTE was providing. Of course, LTE would be LTE Advanced or LTE Advanced Pro. 28 gigahertz was more interesting. Pretty good coverage, not as bad as some people have indicated, but the propagation characteristics are really interesting, and it kind of goes back to some of the early work that Ted Rappaport did about the multipath, the signals bouncing around. In one case where they did a walk test and they looked at what cell sites the phone was connected to, there was actually a connection to a cell site a block and a half away that was actually pointing away from the phone. But the difference was it was reflecting off a glass building and apparently enough signal to get to the phone. and the data rate was still 200 megabits per second.
Oh, that's good.
So pretty impressive. So the report overall is positive. They also looked at what they called the grip of death. You know, people worry about the hand holding the phone is going to destroy the propagation. Didn't find that to be the case. And they also did an analysis of the battery life of the phone, a Galaxy S10. Said, you know, with their particular use case that they thought was reasonable, the phone should last for 14 hours. So
wow.
Overall, a very positive outlook, and Qualcomm wanted them to put all this information together. Much of it they had gathered even before Qualcomm asked them to, but to try to provide a snapshot here 6 or 8 months into 5G deployment.
Well, turning to events, I was just recently at the Mobile World Congress Los Angeles. So that used to be CTIA,
right,
being taken over by GSMA a couple years ago. And I think it's good for RF engineers because they really still are focusing on the technology, and it's not just all about the accessories that CTIA seemed to be getting toward for a while there.
Mm-hmm.
But the big hot topic was dynamic spectrum sharing. And what this is it allows you to do 4G and 5G signals over the same spectrum. So you divide up the channel and you can do like half 4G, half 5G. And then the 4G phone will only pay attention to 4G and 5G vice versa. So why is this important? It's for the low band rollouts.
Yeah.
So when you're doing low band rollouts in rural areas, the number of 5G users is going to be very small. So there's no way you're going to justify the case financially. But if it allows you to share both 4G and 5G together, it makes a business case much more compelling. So that was a topic. Andreas Ressler from Rohde & Schwartz gave a nice technical talk on that.
Interesting.
And it was packed. I mean, there was standing room only. So he had over 100 people listening
Wow.
to that. And then I always like to follow the millimeter wave phased array technology. And there were quite a few announcements there. Movandi and Korea Telecom announced that they will be demonstrating an O-RAN compatible 5G radio. And then we had a release from Sivers and NXP saying that they will supply RFICs for millimeter wave 5G. So they enter the realm of ADI, Qorvo, Anoki Wave, et cetera.
Right.
And I saw a couple demos there, and Pivotal had a demonstration where they were relaying the signal around a corner and then through the glass into their unit inside. And they were getting good results, so that was pretty interesting. And they used the holographic beamforming technology.
Right.
And so I saw a new technology there from an antenna company, and they are doing a dielectric resonator-based antenna system for millimeter wave applications. And what's really neat is it's polymer-based, so it can just be molded directly on the PCB material.
Interesting.
And it gives you an improvement in performance. A lot of the commercial phased arrays, when they go beyond plus or minus 45 degrees, they significantly lose power. But with the dielectric resonator antenna system, they can go plus or minus 60 degrees and still not lose much signal.
Oh, interesting.
And I think because of the isolation between the elements is better, you also might be able to reduce the spacing. So it has a lot of advantages. It'd be interesting to follow this.
Yeah. So how would you compare Los Angeles to Barcelona?
A lot smaller.
Not as many crowds, I
Not
guess.
as many. I mean, it was still a significant event, but it's nowhere near the size of Barcelona. But on the other hand, it's really good because you can make it to everything. You
Right.
don't have to, divide and conquer and only do a few halls, because it's just pretty much two halls, and most of everything we'd be interested in was in one hall to the
Oh, that's
left.
good. Yeah. Well, you didn't get your steps in, though.
I didn't.
Well, next week I'm heading, as you know, to the Association of Old Crows conference in Washington, so I'll report on that in our next episode. And I think that's it.
It is.
Well, we want to thank you for watching this episode. We also want to thank our sponsor, MACOM, for making it possible. MACOM is your partner from RF to Light. Until next time.